Good afternoon, everyone. So, welcome to my YouTube channel, Maths Sopra. So, today we are going to see one of the important question. If f is convex function on interval I and differentiable at some point x naught, then f dash at x naught into x minus x naught less than equal to f at x minus f at x naught for all x belongs to interval I. Okay. So, make note that this is I is interval here. Okay. So now we will solve here this question. I is interval here. Okay. So let T is this range. Then f x naught plus T x minus x naught minus f x naught upon T. What is this? This is equal to f T x plus 1 minus T x naught minus f x naught upon T. Because function is convex, now we can use this inequality. T will come out as minus plus 1 minus T f x naught minus f minus f x naught upon T. Okay. So solve it. What is this? This is T f x plus 1 plus f x naught minus T f x naught minus f x naught upon T. So this is what you take T common upon T. So T is cancel out. So this is fx minus fx naught. So this implies fx naught plus T x minus x naught minus fx naught, okay, upon T is less than equal to fx minus fx naught for all x belongs to I. Okay. So let's say this is equation number 1. Now put h is equal to T x minus x naught. Okay. Then if T tends to 0, then H also tends to 0. Okay. So now limit T tends to 0, f x naught plus T x minus x naught minus f x naught upon T. We can write it by dividing limit T tends to 0, x minus x naught f x naught plus t x minus x naught minus f x naught upon t x minus x naught. We can put in place h here in place of this. So what will be this? So this is equal to, this will come out and this will be limit h tending to 0 f h naught plus h minus f x naught upon h. What is this? This is nothing but derivative at, this is derivative at x naught. So this is derivative at x naught. So this implies limit t tending to 0 f x naught plus t x minus x naught minus f x naught upon t is nothing but f dash x naught x minus x naught for all x belongs to I. Okay. So letting t tending to 0 in 1, we get limit t tending to 0 f x naught plus t x minus x naught minus f x naught upon t is less than limit t tending to 0 f x minus f x naught. But this is constant. It does not depend on t. So it will be same as it is. So both the limit exist. The left hand. What is this limit? This is f dash x naught f. This limit is okay, and this is x minus x naught less than equal to, what is this? This is this will remain as it is. So this is independent of t. Okay. So we have this one from equation number 2. For all x belongs to I. So this is proved. Okay. So this question is done. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for this question. Thank you very much.